Hi all, welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to take chapter complex numbers and quadratic equations of first year PUC. Let us write the chapter name, complex numbers and quadratic equations, and this is for first PUC. I mean to say this chapter is under first PUC, and the marks expected from this chapter is 4 plus marks. Okay, a very easy simple chapter. Even though the chapter name is contains quadratic equations, we are not going to have anything about quadratic equations. Only we are going to have complex numbers, only one exercise. Now let us start with the chapter. Before understanding what is complex number, let us try to understand why do we need complex number first of all. Okay, what is the reason behind? Now we know linear equations. When you talk about equation, that will surely have some roots. Linear equation, quadratic equation, cubic. When I say linear, highest degree should be 1. For quadratic, the highest degree should be 2. Now you just see this equation. We want the solution of this equation, x square plus 1 equal to 0. It's a quadratic equation. Now when we want to solve this, solve for x square is equal to minus 1. Taking the square root on the both the side, x is equal to plus or minus root of minus 1. Now we have a table. Recall from our school days, under the root it should never be negative. Should be either positive or 0. So under the root negative is not a real number. So mean to say that we don't have any real number which can satisfy this. So we mean to say that there are some quadratic equations, for example like this, where real number is not sufficient to give us the roots of this quadratic equation. That's the reason we need what? Complex numbers. To be specific, no, let me take one more example. See this. If I take this quadratic equation, solve for this. X square is equal to 1. X is equal to plus or minus root of 1, which is nothing but x is equal to plus or minus 1, which is a real number. So this is also a quadratic equation, this is also a quadratic equation, but this quadratic equation has real roots. But this quadratic equation don't have real roots. So there are some quadratic equation for which real number is not sufficient. Because of this reason itself comes now complex numbers. So I hope you have understood why there is a requirement of complex numbers. Now let us understand the definition. What is complex numbers? Any number of the form z is equal to a plus ib, where both a and b are real numbers, and this I, which we call iota, is going to represent root of minus 1. So whatever we had a problem here, no, with the plus root of minus 1, that will be taken as I, the iota. Now let us try to understand some more in detail. Here A is called real part, and we denote it as RE of Z. RE, the first two letters of the word real. So RE, whichever the complex number we are talking about, and is equal to what? A. So real part is denoted by RE of the whichever complex number we are talking. What about B? Be careful. I am talking about B, not IB. How to different and for this is called imaginary part. And we denote it as Im of Z is equal to B. This we call imaginary part. Again, the first two letters of the word imaginary. And here what I want you to focus is you can see here I is not included, which is present here. The multiple of I, which is b here, plus b here, is the imaginary part. Whereas this is not a multiple of I. So any real number, when it is expressed in this form, the number which is not a multiple of I, that is known as real part. The other number which is multiple of I, that is known as imaginary part. I hope this is clear. Okay. And both are real, mind it, both are real numbers. Next, some more terminology let us understand. Purely real. What is this purely real? That is something like pure ghee, nothing but no milavat, no adulteration. Similarly, when I say purely real, other than real part, I should not have anything. So in this complex number, we have two parts, which are those real part and imaginary part. When we say purely real, I want only real part. I don't want the imaginary part. Nothing but imaginary part B should be equal to 0. So as soon as we say purely real, imaginary part should be 0, due to which this will become Z is equal to A. So whenever you see only real part present, we call it as purely real, nothing but imaginary part should be 0. Now coming to purely imaginary. When we say purely imaginary, I should have what? Only imaginary parts. I should not have real part. What is imaginary part? Any number which is multiple of I. So here it is B, which is multiple of I. So this should be present. A should not be present. So A is equal to 0. As soon as A is equal to 0, this becomes Z is equal to only I into B. Other than imaginary part, we don't have anything. Now in this, you should understand one most important thing. If you come with respect to subsets, don't forget, we have discussed in chapter 6 that natural number is a subset of whole number. This is subset of integer. Again, subset of what? Rational number. Subset of real number. And irrational number t is also a subset of real number. Now, and also R set of real number is union of both rational as well as irrational. Now see this point. What is A and B? Both are real. Now here A is what? Real. Nothing but this is of the form. Always we are going to have real part here, no? So like Z is equal to 10 minus 3, okay, 11 or root 2 or 2 power like this here. Again 2 power 3 by 2. This is irrational, irrational. This is rational, rational, rational as well as integer. These two are natural number. This is integer, all the three. Whole number is 2. So mean to say that as soon as purely real is actually what? Real number. And definition of complex number is Z is equal to A plus IB. As soon B is 0, I get this part. Nothing but every real number is a subset of complex number C. Complex numbers we denote by capital letter C. So the biggest of all or universal set is complex number C. Even R is also a subset of complex number. As soon we can see here purely real. So for this chapter, throughout our first PUC, I mean to say, and second PUC is always real valued function. I think, but it is going to go with this first line. I think, but R is the ultimate. But coming to complex numbers, this is the only one chapter, complex numbers, where you are going to have a talk about complex numbers. And here we understand that the biggest or the universal set is what? Complex numbers. Okay, kindly make a note, and this will be a very important point to be remembered. And this one we understood because of these two concepts. Kindly make a note of this. Let us move on to next concept. See, let us first try to understand regarding powers of I. Okay. Now we know that we just denote square root of -1. In place of writing this, we are just writing as iota I. As soon you see, we talk about complex number, as soon you see I, it is understood, it is denoting root of -1. In place of writing like this, we are writing iota, nothing else. Iota I. Now let us try to see the different powers of I. If I square on both the sides, I square is equal to root of -1. As we know, square root and square will get cancelled. So, actually what's happening here? -1 power. What's the root value? Power half. And I've got power 2. So 2 and half will get cancelled. Therefore, I will get I square equal to -1. Okay. Next, if I multiply I here, both the side, I square into I -1 into I. What we did here? Multiply I on both the side. Multiply I on both the side. If you are, marker. If we are, marker I forgot, black color. If we multiply I on both the sides, let's write properly this. Multiply I on both the sides. Now, from school days, we know bases are same, we can add the power. What is a power m into a power n? It is a power m plus n. Whenever bases are same, add the power. Here the base is I, here also I. So here the power is 1. 2 plus 1 will be 3. -1 into I will be -I. One more result we have got. Next, again for this, if I multiply by, okay, sorry. I again on both the sides. What will happen? I cube into I is equal to -I into I. Again, bases are same. We can add the power. Here power is 1. 3 plus 1 is 4. Minus I into I square. But what is I square? From here, -1. So I square is -1. Minus to minus plus 1. This is I power 4. So I power 4 is 1. I cube is -I. I square is -1. And I, as we know, root of -1. Now, let us try to again multiply I for this. Let us see what's happening. So, what we have already, I power 4 is equal to 1. Let us copy again. Now, if I multiply by I again on both the sides, whether I give dot or into sign, understood, multiplication. Now, here bases are same, add the power. 4 plus 1 will be 5. And 1 into I is I. Oh, see, I got back this. Let us try to find some more. Again, if I multiply by I power 5 into I is equal to I into I. I power 5 into I will be I power 6. I into I is I square. But what is I square? -1. What can we see here? Values started repeating. First I got, after I power 4, I got this one first back. Now again I'm getting this. So that's nothing but next I should get back this. Let's see. Again multiply by I. So what will you get? Into sign. I power 6 into I will be I power 7. Nothing but here. -1 into I is -I. Oh. See this. I power 7 is matching with this. Again multiply by em. I. Bases are same. Add the power. 7 plus 1 is 8. Minus I into I square. But what is I square? -1. So be careful. Minus as it is. Then I square is -1. And minus is plus 1. I power 8 is 1. We got back this. Nothing but after reaching power 4, the values are repeating again back. Okay. Next. Having understood this, we can think of generalization. But before that, many students will be thinking, no, square is there. So this negative convert to positive. Observe the previous step. Here I into I is I square. This minus is outside both, or it's a multiple for both the i's. If it was something like this, minus I the whole square, then this square will convert negative I to positive I, then I square is minus 1. I hope this point is clear. Now from this, we can think of generalization of this result. We can generalize this result. See carefully from here. One thing is very clear. After I power 4, all the values are repeating. I power 5 is coming back to I power 6 is coming back to I square value. Nothing but minus 1. I power 7 is coming back to I cube. And I power 8 is coming back to I power 4. Now, from this, what we can generalize, understand. First, I power, whatever multiple of 4 is there, I power 4n is always 1. Next, I power 4n plus 1 is same as I power 4n into I. By using law of exponents, I am going from right to left now. I power 4 is what? 1 from here. 1 into I is what? I itself. Okay, if you want, I will write step by step. I power 4n is 1. 1 into I is I. Next, I power 4n plus 2. Again, by using law of exponents, I can write I power 4n into I square. What is I square? Minus 1. So we are going to have I power 4n into minus 1. So this we are going to get as minus replaces minus. So I'll get minus I power, some other color. I power 4 is what? 1. Correct? No. So what will we get ultimately? 1 into this is what? 1. 1 into minus 1 is what? Minus 1. Then what is I power 4n plus 3? It is I power 4n into I cube. Again, I power 4n is from here 1. But what is I cube minus I? So generalize the things. Very, very simple. Let us again write this and understand. I power 4n is always 1. I power 4n plus 1 is I. Next, I power 4n plus 2 is minus 1. Next, I power 4n plus 3 is minus I. These are our important results. I hope this is clear. And wait, n is any natural number. If it is negative power, we are going to take it denominator, then we are going to solve. Okay. Now first, let us understand how to remember this. Because as in the powers are higher, no, we cannot always express like this. Always we are going to write as multiple of 4. Multiple of 4. Now how to remember? It's very simple. Anyway, I power 4n 1. Now you see here, after expressing whatever the power is there in terms of multiple of 4, whatever remainder is there, that's the power here. See, I power 1. Here, actually here what's happening? What's the remainder of this? I square, correct? No, actually what we got here? I square. Let us write it again here. I square. What is I square? Minus 1. Again the remainder is coming here. Similarly for this also, I power 4n plus 3. When I have evaluated here, what I got? I cube into 1 with what? Here this is 1. 1 into I cube is I cube. That I cube value is minus I. That's what final answer minus I. But if you go step by step, this is I cube. And this I cube is minus I. What I'm trying to comment and make you understand is, as soon you express in the form of powers of 4, whatever remainder is there, that power you have to consider to get the values of powers of I. Okay, I hope this point is clear. Now, having this information, and you have to make sure memorize it. One last point let us discuss here itself. Note, what if we sum 4 consecutive I? Presently, I square, I cube, I power 4. What? I I square, I power 3, I power 4. I remains I. What is I square? Minus 1. So I square is, this is I as it is. I square minus 1. I cube minus I power 4, 1. So minus I for I cube, and this is 1. See carefully what's happening. Can you see? Minus 1 plus 1 will get cancelled. Minus I plus I will get cancelled. As is what? 0. So sum of 4 consecutive power I have taken is 0. But now the question is it a general result or it's a coincidence that we got 0? For that, we can have an answer. Let us erase the last point. Anyway, I hope you have copied all. See this. Let us write it here only. Who knows, for 1 mark it will be very useful. See, coming to the second note, in general, if we take nothing but this powers, I power 4n plus I power 4n plus 1 plus I power 4n plus 2 plus I power 4n plus 3. I was looking 4n, or like next line, plus I power 4n plus 3. I power 4n, what's the value? 1. What is I power 4n plus 1? I. What is I power 4n plus 2 value? Minus 1. What is I power 4n plus 3 value? Minus I. That's what here, no? See carefully what's happening. Is it not? Plus 1 minus 1 will get cancelled. Plus I minus I will get cancelled. As is what? 0. So it's not a coincidence here. It's in general. If you have 4 consecutive powers of I, the sum of them is always equal to 0. A very important and useful result. Okay? Kindly make a note of this. Okay. Dear students, let us move on to equality of two complex numbers. When do we say two complex numbers are equal? Then we'll take some small problems. Okay? Listen carefully. Equality of two complex numbers. When do we say the complex numbers are equal? Let's have a capital C, complex numbers. So let us suppose that we have got two complex number. Since we gave the definition as z is equal to a plus ib, so I'll keep z1 for first complex number, and it is a plus ib, and the second complex number z2 is c plus id, where we know a, b, c, d all are what? Real numbers. Then if this is given, then z1 is equal to z2, nothing but both the complex numbers are equal if and only if and only if, in short form, right, IFF. So if at all it should be the given two complex numbers are equal, then the real part of the first complex number should be equal to real part of the second complex number, nothing but a should be equal to c, and imaginary part of the first complex number should be equal to imaginary part of the second complex number, nothing but b is equal to d. Only under this criteria, these two complex numbers are what? Equal. If this condition is not satisfied, then the given complex numbers are not equal. Okay. Now let us take some simple problems on this. First, let us suppose that if I have been given z is equal to 3 plus 4i. See whether it's like this or you write like this. Both are same. Okay. There's no such condition that I should be right of the number or it should be left of the number. Just as soon as I see, since I is present, it's understood it is equal to root of minus 1, therefore it's a complex number. Now in this, which is the real part of the complex number, in short we write RE, real part of complex number z. As you can see, 3 is a number which is not a multiple of I, therefore real part is 3. Coming to imaginary part of the complex number z, since 4 is multiple of I, therefore imaginary part is 4. That's it. Similarly, let us suppose one more question. Recording, no? Always no. If z is equal to, I'll take the same problem here to make it very clear. Now here, what is the real part? Which is that complex number, which is not a multiple of I? It is 3. So real part is 3. And what about the imaginary part, which is that number multiple of I minus 4? Let us suppose in the exam they give like this the question. Then also it is what? Minus 4. Minus into plus is minus. Similarly, if I have got minus, for example, suppose I have got minus, let us write one more problem. If we have z is equal to minus 3 minus 4i, then what will be the real part of z? It is minus 3. And imaginary part of z, what it will be? Minus 4. Okay. I hope this point is clear. Now let us try to take some problems on powers of I also. I will try to take problems from NCERT. Let's have no that those problems are also solved. Okay. First, make a note of this. Dear students, I have taken example number 1 on equality of two complex numbers. Question says, if 4x plus I times of 3x minus y is equal to 3 plus I times of minus 6, where x and y are real numbers, then find the values of x and y. We have to find the values of x and y. Now let us first take the question. 4x plus I times of 3x minus y is equal to 3 plus I times of minus 6. Now first, group as real part and imaginary part. It's already grouped. Correct? So now, equating two complex numbers. When do we say two complex numbers are equal? Real part should be equal to real, imaginary part should be equal to imaginary. Let us write it here also. Z1 is what? A plus IB. And what is Z2? C plus ID. So real part should be equal to real part, imaginary part should be equal to imaginary part. Here the real part is 4x because this is not a multiple of I, and here it is 3. So 4x is equal to 3 cross multiply, x is equal to 3 by 4, and it's a real number. That's what they said, both are real numbers. Next, equating the imaginary part on either side, we have 3x minus y is equal to minus 6. Here x value is 3 by 4. I will take this as equation number 1. Substitute here. Then minus y is equal to minus 6. If I transpose, so I'll get 3 3s are 9 divided by 4. Minus 6 will become plus 6 is equal to y. Nothing is means what? 1. Every natural number is a rational number. In chapter 6 we have discussed. Always I can write for integer, whole number and natural number as divided by 1. Number given by 1. So LCM of 4 and 1 is 4. 4 by 4 will be 1. Multiply that in numerator. 1 into 9 is 9. 4 by 1 is 4. Multiply in numerator. 4 6 are 24. 24. Does I write properly 4? 24. Sorry. 24 is equal to y. Add this, you will get 33 divided by 4. This will be the value of y. So for 1 mark, who knows? They may ask a question. Kindly make a note of this. Okay. Dear students, having understood the concept, let us take some problems, very basic problems on this concept for 1 marker. Okay. From my end. Okay. See, let us suppose question number 1. Let us suppose that we have given a complex number z is equal to 3 plus 7i. Okay, minus 3 plus 7i. Now, then we want to know what is the real part and imaginary part. The real part of z. Real part is the number which is not a multiple of I. Here minus 3 is not a multiple of I, therefore real part is minus 3. Whereas imaginary part of the complex number z is 7, as 7 is multiple of imaginary unit I. Okay, let's take one more example. If we have z is equal to 6, okay, minus 6 plus, okay, let us have like this only, minus 6 and minus 6i. Now be careful, the presence of this minus 6 indicates the real part of z is minus 6, and the presence of this I multiple, that is minus 6, gives us imaginary part of z is what? Minus 6. So I hope this is clear regarding how are you going to recognize real part as well as imaginary part. Next, let us try to also go for some problems from NCERT text on with respect to the powers of I. First, make a note of this. Okay, dear students, I have taken from exercise 4.1, express each of the complex number the given below. I mean to say I have taken the question from 4.1. They want in the form of a plus ib. They need not give like this, and they may say express the given complex number given below in standard form. Standard form is what? Definition. Now what definition says? Any complex number is of the form z is equal to a plus ib. Nothing but the power of I should be 1. Now just see here. First problem, whatever we have got here, it is 5i into minus 3 by 5 into I. 5 and 5. 5 by 5 will get cancelled. Plus into minus, minus. I into I will be I square, and this 3 as it is. We are just going to multiply, just multiplication, basic multiplication. Then, what is I square? Minus 1. Minus to minus, plus 3. 3 same as 3 plus I into 0. I square value is minus 1. Don't forget. That's why I square value I wrote as minus 1. Now you see this. Here the powers are more than 4. So as I said, we are going to express whenever we have got power more than 4, express as powers of 4, and the remainder will decide the power. Now here, coming to this, 4. 4 2s are 8. I want either, see, I have to choose such a multiple here. Either should be equal to this. It can be equal to this provided the number given to us is multiple of 4. Otherwise, we will be having, as soon as I multiply, I'll be having a number either more than this or less than this. Always you have to go either equal to the whatever the power given or just less than, not beyond that. Okay. So 4 2s are 8, but I want 9, so plus 1. Plus I power 19 is there. 4 table. 4 4s are 16. Okay. Plus 3 will give us 19. Now, as I said, just take the remainder. This is the remainder. I power 1. And here, I power 3. No need to even remember that, no? I power 4n, I power 4n plus 1, etc. If you just remember, I square is minus 1, I cube is minus I power 4 is 1. Sufficient. But better remember, okay? Don't be so choosy also, okay? I power 1 is I cube is minus I. Both minus I plus I will cancel. The answer is 0, which is same as 0 plus I into 0. When I gave the concept, I said be careful with the what? Negative power. If you have negative power, how to solve? I just want to make an attempt for you to understand. 1 divided by I power 39. Now, multiple of 4. 4 9s are 36. 39 we have. So 4 9s are 36 plus 3. Okay. Then, remember this what? 3. I cube. What is I cube minus I? Now we are going to multiply and divide by its conjugate. See, in school days, you used to have no, whenever denominator is irrational number, you used to multiply and divide by its conjugate. So, 1 plus by minus is minus 1 by I. Let us complete here only. Let us give this as a standard formula. Let us work out and how to get. Okay. Multiply and divide by its conjugate. Nothing but when I say conjugate, you have to change the sign of imaginary part. So 1 by I multiply by minus I and divide by minus I. Plus into minus minus. 1 into I is I. Again, minus to plus is minus. I into I square. Negative will get cancelled. What is I square? Minus 1. So I will get I divided by minus 1 because I square is minus 1. Plus by minus is minus. So this implies 1 by I is equal to minus I. I repeat, 1 by I is equal to minus I. So this 1 by I is what? Minus I. This minus as it is. 1 by I is minus I. Minus to minus plus I. I same as 0 plus I. So among the four, one more result you want to I want you to memorize is 1 by I is minus I. Okay. Now see this one question I will take. Fourth question, not in textbook, from my end. I power 4,700 and some number, 98. Okay, some more number. 47,985. Now, by the time you'll take calculator, see all that, no, it will take time. There's one more way also. Divide by 4 this, then whatever the answer you'll get, don't take the decimal part, take the integer part, multiply by 4, then you'll come to know what's the number actual. That's all lengthy, not all required. See the trick in case you get this type of question. Only focus on last 2 digits, nothing but unit and 10th digit. And for that number 85, you think of dividing by 4 and get what? The remainder. So if I divide, what you are going to have? See carefully. 4 2s are 8, 4 1s are 4. Plus 1 will give 85. So divide by 4 right here. Okay. But we have divided. No, here we have divided. Enough. So you can see LCM is 4. 4 2s are 8. Yes, 85. So my remainder is 1. So answer is for this is I power 1, nothing but I itself. Again I repeat. Listen carefully. Whatever you have got last 2 digits, whatever number it will be, number in terms of 100, 1000, 10,000, 10 crore, whatever, only focus on last 2 digits. Divide by 4 because it's a cycle of 4. Whatever remainder you get, no, for last 2 digits, same remainder you get for the entire also. So 1 is the remainder, so I power 1. Okay, and I power 1 is what? I itself. I would like you to comment in the comment section what could be the answer for this question. This is your challenge. Okay, fine, make a note of this. Okay, dear students, having understood the basics, let us move on to some more properties. We have understood just about the complex number, when they are equal, powers of I, all that. Now comes algebra of complex numbers. See, same like school days, no? After learning numbers, then how to add those numbers, subtract, multiply, divide. Similarly here also, we know about complex numbers. Now, what are the different operations we can have, and along with the properties. Let us take one by one. So, first, let us have the algebra of complex numbers. Algebra of complex numbers. How are we going to perform the different operations? Now, under this first one is addition. Before that, let us define the complex numbers for a while. Let us define the complex numbers. So, minimum we have want 2, numbers. So let us suppose if z1 is equal to a plus ib, and okay, we'll do one thing, give subscript like this, so that when we just write everything, no, since I have got one for both a and b, it is a complex number of the form this, nothing but z1 is a complex number. Similarly, z2, a2 plus ib2. So because of the index system, no, we'll come to know which complex number we are talking about in the explanation part. So if these are the two complex number, then how are you going to sum? Nothing but addition. Coming to the addition part or sum, whatever, no, sum of these two complex number. So how are we going to sum? Very simple. You are going to add real part with real, imaginary part with imaginary. So a1 plus a2 plus, see, a1 plus a2 over, then b1 plus b2, I times of b1 plus b2. Next, how are we going to take difference or subtraction of two complex numbers? Let us go step by step in this case because minus is there. Z1 is A1 plus IB1 minus Z2 is A2 plus IB2. Again, many will miss the bracket. If you are missing the bracket, minus is multiplied only to A2 but not for IB2. Be careful. Minus is for the entire complex number Z2. Z2 is entire, so bracket is mentioned, to be mentioned. So A1 plus IB1 minus with plus is minus A2 minus with plus is minus IB2. Now A1 minus A2. How we are going to add or subtract? Real with real, as you can see here, imaginary with imaginary. So here plus I, okay, I here, this common in this two. So now what's remaining here? B1 minus B2. B1 minus B2. This is our complex number Z1 minus Z2. So in short, how to add and subtract two complex number, real with real, imaginary with imaginary. Now comes about multiplication. How are you going to perform product or multiplication of two complex number? Let us take one minute, no problem. Multiplication of two complex numbers. So Z1 into Z2. What is Z1? A1 plus IB1. A1 plus IB1 into Z2. Z2 is A2 plus IB2. A2 plus IB2. Now in school days, how used to multiply two numbers? If the bracket is given, you are going to multiply each and every term, right? I mean to say, this A1 should be multiplied to this part also, and it's nothing but real and imaginary part. So same way. So we are going to have A1 into A2, then plus into plus is plus, then I as it is, then A1 into B2, then from here to here, plus into plus is plus, I, okay, as it is, B1 into A2, then plus into plus plus, now multiply from here, I into I is I square, then B1 into B2. Now we know already what is I square, it is minus 1. So this will be minus 1. So here A1, A2 plus here if you see this two term, common is I. So if I take common I out, nothing but I am adding these two complex number. So A1, B2 plus B1, A2. And here I square is minus 1. So B1, B2 as it is. Plus into minus, minus B1, B2 I write here. And here A1, A2 as it is. Then plus of A1, B2 plus B1, what? 8. This is about multiplication of two complex numbers. I am not asking to memorize any result here. I just showed that we have to multiply each and every term. When you multiply, surely I into I square. So we have to remember the powers of I there. Okay. Now comes division. How we are going to go for division? But before going to division, I just want to discuss one small concept: conjugate of a complex number. conjugate of a complex number. Conjugate is not something new we are hearing. Okay. For example, irrational number, if we have got, we used to multiply and divide by its conjugate to convert irrational number to rational number, but changing the sign. Same thing here also. If z is equal to a plus ib, then the conjugate of z is given by the symbol z bar. So whenever you see z bar, it means what? Finding the conjugate. How to find the conjugate? We have to only change the sign of imaginary part. Imaginary part is b, so change the sign to minus b. See here this plus, so change to minus. That's it. This will be the conjugate of any complex number. For example, if I say z is equal to 3 minus 4i, then what will be the conjugate of this? Change the sign of imaginary part. Imaginary part is minus 4. Change to what? Plus 4. Okay. I hope it's visible. Z here and here. Z plus 4i. So having understood this, we'll discuss the geometry also shortly. Now comes division. How are you going to perform division of two complex numbers? You want to perform division, but of what? Two complex numbers. Let's take it here. Again, when I'm saying z1, z2, I mean to say this. So I have got z1 divided by z2. z1 is a1 plus ib1 divided by z2 is a2 plus ib2. Obviously, the denominator, that is a2 plus ib2, should not be equal to 0. And what is this? Z2. So either this or Z2 should not be equal to what? 0. Both are understood. We don't want denominator to be 0. If not, we'll get undefined. Now how you will proceed here? Very simple. We don't want, see, in the definition of complex number, definition says Z is equal to a plus ib. So the I is always in numerator, never in denominator. So you see here, in this division, I is there in denominator. So this part should not be there in, this part should be removed. Means I should not be present. So for that reason, what we are going to do is, we are going to keep numerator as it is. Then, I think better, no? First we make a note. I'll let it separately and explain. That will be ideal. Make a note of this. Okay. Okay, see carefully. I'm just continuing this part. I don't want to write it here. Space is not sufficient. See carefully. Again, I will recopy. Z1 by Z2 is equal to A plus A1 plus IB1 divided by A2 plus IB2. So I have just copied the same, but I have I in denominator. We don't want I in denominator because in the definition of any complex number, it is a form Z is equal to A plus IB. The denominator is never imaginary. It don't have any imaginary part. Here we have. So what we are going to do, multiply and divide by its conjugate. As I explained here, for conjugate, you have to change the sign of imaginary part. If it's plus, change to minus. If it's minus, change to plus. So see carefully. Here it is plus. I'll change to what? Minus. See, concept I'm not going to compromise. Okay. Yes, ready? Now, I will be giving all the concept in detail. Now, I'm coming to pronounce the same thing. I'm making sure that which of the columns bit different, which is not in model paper. I'm discussing that also. Okay. Now, this A1 should be multiplied to both the way we have multiplied here. So what we are going to have? Let us multiply this A1 multiply this A1 A2. Then plus into minus minus I A1 into B2 plus into plus is plus I B1 into A2 plus C plus into minus is minus. Here again from here to here, right? Then repeat again here to here. I into I is I square. B1 into B2. All divided by C denominator. This is of the form A plus B into A minus B. Correct? See? School days. What I'm trying to say, no, in place of what? Multiplying them and then cancelling, we can always have this formula because it resembles. And this is what? A square minus B square. Whenever you are multiplying a complex number with its conjugate, you will get A square minus B square form. So here, in place of A, we have A2. So A2 square. Then minus, so minus B. What is C? In place of this B, we have this entire thing as B. And this entire thing is what? A. Similarly here, A minus B. This entire thing is what? A. And minus we get balance. In place of B, this entire thing is what? B. Correct now? So A square minus B. What is B? I B to the whole square. Now again, what is I square value? It is minus 1. So A1, A2 minus, okay, here you see both are imaginary part. We can take I common. If I take I common, minus A1, B2, then plus B1, A2. Okay, minus, or is I square? Minus 1. Then B1, B2 whole divided by A2 square. Okay, now see, squares of both. Here itself, A2 square minus squares of both. So this square should be taken for both. Reason, school days law of exponents. What is A into B whole power n? It is A power n into B power n. So this power should be taken for both the bases. So same thing, in place of A and B, we have I and B2. This square should be taken for both. So what we are going to have? I square, then B2 square. Now let's continue here. A2 square is I square minus 1, then B2 square. Right? What we are going to have? A1, A2, then here plus I of minus A1, B2 plus B1, A2 minus plus B1, B2 whole divided by A2 square minus plus B2 square. I'm not saying again to memorize a mug. No, nothing. Just I wanted to understand how the things is going to happen for division. Whenever in denominator we have any complex number, when they will, and we want to evaluate, we have to make sure denominator should be free from I. It should have only real part, no imaginary part. And as you multiply and divide, you will get sum of the square. This we call magnitude, which we'll discuss shortly. Okay, kindly make a note of this. Okay, dear students, having understood the algebra of derivatives, Dear students, having understood algebra of complex numbers, now let us move on to properties. See here. So coming to properties of complex numbers, let us first understand the properties with respect to addition. Now in this, see, let us try to understand this with the help of real numbers. The first property under this is closure property. Now what is the meaning of this closure property? Okay, see, whenever if I take any two numbers from a set, after perform, the output should be in the same set, that we call closure. For example, if I take two real numbers, 3 and 2, and now if you add this, it is what? 5. Again, it's a real number. This we call closure property. So coming to complex number, whenever you take any two complex number, and if you are going to add, now again the two complex numbers are this, Z1 is equal to A1 plus IB1, okay, and Z2 is equal to A2 plus IB2, and if I add only Z, its the meaning is A plus IB, okay. So if I add any two complex number, the output, as you know, I have to add real with real, so I'll get A1 plus A2 plus I common, then B1 plus B2. The output is what? A real number. It's the output is what? Complex number itself, because I is there. So every complex number is closure property under addition. Next is commutative. What's the meaning of this? See carefully. See, coming to real number under addition, plus 2 or 2 plus 3. Both are equal to what? 5 only. So we can change the order. That's what we call now commutative. So here also, if I have two complex numbers z1 plus z2, even if I add first z2 and then z1, addition will remain the same. So it is commutative property, whole good. Next comes associative. Associative property. Now what this says, if I have got three complex number, so I'm saying three complex number, so z3 which is a3 plus ib3. So I've got three complex number and I want to add. See, recall, let us write z3 properly. Recall, even if I've got three numbers here, one number, okay, let's say 2, then here one was 5, other is 7. At the time you can add only two numbers even though you have got simple numbers. Either you can add 2 plus 5 and then add with 7, or we can have like this, first add 5 and 7 then add with the 2. Similarly here also, either I can add first z1 and z2, or it can also happen that I'm going to first add z2 and z3 then add with the z1. Again I repeat, either I can add z1 and z2 then add with z3, or first add z2 and z3 then add with the z1. It can also happen that you can go this one also. Okay, no problem. Fine, this part is done. Now comes additive identity. What is the meaning of this? See carefully. If I have any real number, let us suppose 5, which number should I add here to get back 5? Think. Which number? 0. Similarly, this is also as 0 plus 5. Both will give you what? 5 itself. Similarly, this, so under real numbers, under addition, 0 is the identity element under addition. So here identity means such a number, if I perform the operation, I should get back the same number whichever I have taken. So this is under addition. Similarly, for every complex number is z. Now when I am saying z, this, okay, I can always add 0, same as 0 plus z, which will give me what? Z. So this 0 is actually denoting 0 plus I into 0, where both real part and imaginary part are what? 0. So this is additive identity. Understand the meaning of additive identity. Under addition, which is the identity element, it is 0, where both real part and imaginary part are what? Zeros. Now comes inverse. Additive inverse. Additive inverse. I mean to say, which is that complex number. If I add, I should get back the identity element. For example, in real numbers, if I have 5, same number, I'll take 5 here, which I have taken here. So if I have got 5, which number should I add here to get back what? Identity element 0. Which number is that? If I add minus 5. Same thing here also. Minus 5 plus 5, both will get cancelled, I get what? 0. That's what, coming to additive inverse, for every complex number z, I can always have minus z. That will give me 0. Same as minus z plus z. So this minus z is called additive inverse. I think what such a number that if I add with a complex number, such a number, if I add with a complex number, I will get what? Identity element 0. Additive identity. Here I am stressing repeatedly additive identity, additive inverse. Why? Because under addition, for example, coming to real number, here you see 5 plus 0 is 5. Under addition, 0 is that number. If I add with 5 or any real number here, if I add with 0, I'll get back a only. Correct? No? Similarly, under multiplication, which number should I multiply here to get back a? Think. Think fast. Which number if you multiply to a, you should get back a? 1. So, under multiplication, 1 is the multiplicative identity and 0 is the additive identity. Now I hope you understood why we are using one prefix word. for this additive, I repeat, for this additive identity, and for this multiplicative identity for 1, and for 0 additive identity, because here the operation is addition. For addition, this will be 0 will be acting as identity element, therefore we use the word additive identity. And here for multiplication, 1 is that number, so multiply with a, I get back a. So 1 is multiplicative identity. I hope this point is clear. Okay, so that's the reason we give this prefix. And here one example we can take, one question: if z is equal to 3 minus 4i, then what is the first question, additive identity, sorry, and additive inverse. 1 marker question, very simple. For let it be any complex number, additive identity is what? 0. First part of the problem is 0. Coming to second part, additive inverse is negative of the given complex number. Be careful, minus z is negative of the given complex number z. So here z is there, so take the negative of this, multiply 12 by minus, so I'll get minus 3. Again, minus into minus is plus 4i. And you can just see, if you add this 2, plus 3 minus 3, 0, minus 4i plus 4i, 0. So I'll get back identity, additive identity. Okay. So I hope this point is clear. Kindly make a note of this. Fine. Dear students, now let us move on to properties under multiplication. Okay. So now presently we are going for multiplication, and I think it's best to take real numbers, school this concept, and then analyze. Things will be very simple. Now again, I'll be taking 3 complex number. Let the complex number z1 be a1 plus I b1. Second complex number z2 is equal to a2 plus I b2. And the third complex number z3 is a3 plus I b3. Now again, if I take 2 real numbers, let's suppose 2 and 3, both 2 and 3 are real numbers, and if I multiply 2 into 3, I'll get 6. 6 is also what? Real number. Nothing but real number is satisfying closure property. Nothing but whichever element you take, when you perform the operation, the output is again in the same set R, set of real numbers. So coming to that first property, yeah, it also satisfies closure property, that if I take any 2 complex number and if I multiply, already we have seen how to multiply 2 complex number. So it is a1 plus ib1 and then a2 plus ib2, and this will be again a complex number C. Second point, commutative. Same what we have got for real numbers. See, if I take 2 into 5, the answer is 10. And so this is same as 5 into 2, nothing but they can change the order. So coming to complex number also, z1 into z2 is same as z2 into z1. Next property, associative. Coming to associative property, ready? So for associative property, again here, if I have got 3 complex numbers, means 3 real numbers, I mean to say. Now again here, 2 into 3 into 7, even though it's a simple numbers, but at a time you can multiply 2. Recording no? Yeah. And this 2 again into 3 into 7. So either you can multiply first 2, then multiply with 7, or 3 and 7, then multiply with the 2. So Z1, Z2, Z3. Either you can first multiply Z1, Z2, then multiply with Z, I mean to say Z3, or we can first multiply Z2, Z3, then multiply with Z1. Everything is the same. Okay, again we can multiply Z1, Z3, then multiply with the Z2, no issues. Because commutative is 2. I can think of exchanging here, both here and addition, because commutative is 2, otherwise not possible. Okay, that I can take Z1, Z3 because we are extending this 2. Now, next, existence of what? Multiplicative identity. Multiplicative identity, nothing but with respect to multiplication, which is that number, which is going to be that number, if I multiply to get back the same number. For example, coming to real number, if I have got a number a, which number should I multiply here to get back a? It is 1. Correct? No? So similarly here also, for any complex number z is nothing but a plus ib. For every complex number z, if I multiply by 1, I get back the same complex number. Okay? And I can change the order. Here, 1 which is same as 1 plus I into 0 is multiplicative identity. Multiplicative identity. For 1 marker question, who knows, they can ask. Next, fifth one. What could be multiplicative inverse? Nothing but existence of multiplicative inverse. I mean to say, for every complex, okay, first let's talk about real number. If I have got a real number a, which number should I multiply here to get back 1? It is 1 by a. So it means a should be non-zero number. For 0 it's not going to hold good. And again the same as 1 by a into a will give you 1. Nothing but multiplicative identity with respect to real numbers. Similarly, for every complex number z, if at all I want 1, I should multiply by 1 by z. Here also same thing, 1 by z into z will give us 1. So where this 1 by z, which is same as 1 divided by what is z? A plus ib. So this will be what? In denominator is what? Multiplicative identity. Multiplicative inverse, multiplicative inverse. I'll also discuss how to find this multiplicative far away spelling wrong. Multiplicative inverse. Yeah, now fine. Okay, we'll also, and this 1 by z, we denote this 1 by z as z power minus 1. Okay, we are going to denote like this. Shortly, I will just say you after I erase how are you going to find multiplicative inverse after discussing 2 small concepts. Now, last one is distributive property. Distributive property. I think space is not there. We take after erasing. Make a note of this. Fine. Dear students, let us move on to the concept. Just now we discussed about multiplicative inverse. Now let us try to understand distributive property. Focus. Distributive property and the multiplication only. So I think 1, 2, 3, 4. Fifth point. No, 6th point it is. Correct? No? 1, 2, 3, 4, 5. Yeah, 6th point. Now let us suppose again 3 complex numbers are there. And here Z1 is being multiplied to addition of Z2 and Z3. This I can just multiply this usual way. So I'll get Z1, Z2 plus Z1 into Z3 will be Z1, Z3. Z1, Z3. Okay, or the other way around. I may have Z1 plus Z2 and this is multiplied to Z3. Then again this Z3 can be multiplied to Z1 as well as Z2. See this for 1 marker, no, better to know everything, because in maths they might have given the property question on the concept of property and they might have asked which of the following is false. And let us suppose that one of the option is the plus is there but here again minus. So this particular option will be wrong, correct? No? So it's concept oriented purely. Now let us try to understand 2 concepts and then we'll also take eigenplane, nothing but the complex plane. See carefully here. If I have a complex number z is equal to x plus iy, I can take whichever alphabet I want. Both x and y are real numbers. Then first point, what is magnitude? Other name for this is modulus of any complex number. Modulus. It is denoted by mod of z. It is square root of sum of the square of real part and imaginary part. Nothing but x square plus y square. Next point is, what is conjugate of, already we have defined, let us have again here, conjugate of complex number. Already I defined. Let us have again. I want to just discuss a geometrical representation of this. So conjugate of this complex number, that is z is equal to x plus iy. The conjugate is denoted by z bar and this will be x minus iy. Change the sign of imaginary part. Let us take one problem to understand this too. Let us suppose we have one question. Okay, before I take the question now, let us try to understand what is that inverse, multiplicative inverse which we are discussing now. Let us try to get that. Okay. So third point, how to find multiplicative inverse. Because of this, I have defined these 2 concepts. Multiplicative inverse, what we said, such a complex number. First, z is a non-zero complex number. So if I multiply 1 by z, I should get 1. Simple, no? Both are going to get cancelled. Now this 1 by z we denote 1 by z as, z power minus 1. Now we want to find this. That's our target. And don't forget z is a plus, okay, here you have taken x plus iy, so I'll continue the same. Since I have taken x plus iy, let us have throughout x plus iy only. Now see, I want to find multiplicative inverse, nothing but z power minus 1, nothing but 1 by z. Substitute here, 1 divided by x plus iy. Now, let us try to remove I from the denominator, as I discussed previously also, that coming to definition of complex number, any number of the form z is equal to x plus iy. I is always in numerator, it's not in denominator. We have in denominator. So what we are going to do, multiply and divide by its conjugate. So conjugate of this will be x minus iy, and this one as it is, into divided by denominator x plus iy. So I am multiplying and dividing by its conjugate. Okay, clear? Again I repeat, whatever I wrote, same thing I have copied here. Then the conjugate of this is what? X minus iy divided by x minus iy. I have multiplied and divided. Why, sir? I can cancel and I can get back the previous step. Only then I get equal sign. Now 1 into anything is same thing, divided by, this is the form a plus b into a minus b. What is a plus b into a minus b? We get a square minus b square. So in place of a, we have x. In place of b, we have I into y. So we can write this one now as, in place of b, we have iy. Okay, iy. Write it here. A, in place of a, we have x. In place of b, we have iy. Again, if you compare also, in place of a, x minus the balance, in place of b, iy. Put here x square minus iy the whole square. Now x minus iy divided by, now recall the law of exponent, a into b whole power n is same as a power n into b power n. So x square minus I square into y square. What is I square? What is I square? Minus 1. So we are going to have x minus iy divided by x square minus I square is minus 1, then y square. So ultimately what we are going to get right here? What we are going to get? Let's continue. Okay, I'll continue here. That's better. What we are going to get? See carefully. We are going to have x minus iy divided by, minus what? Plus x square as it is, no? Minus plus y square. We got x square plus y square. This will be what? Our multiplicative inverse. Either I can say it is z power minus 1 or 1 by z. This is the inverse. Now let us try to write the right hand side in terms of z only. So if you see the numerator, if I compare with this x minus iy, yeah, x minus iy, we have got conjugate of complex number. So the right hand side z conjugate. Next come to denominator x square plus y square. If you see this is same as, take squaring on both the side. I will get this one to be x square plus y square. Root s will get cancelled. So x square plus y square is mod of z the whole square. So the denominator of this is what? Mod of z the whole square, and the left hand side as it is. This will be our multiplicative inverse provided mod of z not equal to 0. That's what you are saying, that complex number inverse exists under multiplication provided complex number is non-zero. So this will be our important formula to find the inverse. I will be having usually 3 marker or 2 marker question. I hope this point is clear. Kindly make a note of this. Okay, dear students, now let us discuss Argand plane or complex plane. Let us understand this. Argand plane, or the other name complex plane, both mean same. Okay, first again recording. No, oh, yes. Now what is this Argand plane or complex plane? Understand this. See, coming to Cartesian system, coming to real numbers, what you used to plot x and y axis, both are mutually perpendicular. Each number with real numbers, correct? Now, as soon we bring complex number, the same Cartesian plane we are going to regard as Argand plane or complex plane. As soon the Argand plane, complex plane come into picture, it means that we are talking about plotting of complex number. And this now we are going to represent in the form of a point P, and the coordinates are x comma y. And coming to the coordinate, always my first, in the coordinate, the first, in this order to the first value, this will be always my real part. As you can see, x is a real part, and this y will be imaginary part. Okay, imaginary part. So now let us try to understand still better. Let's have a plot. So we are going to have same x and y axis, and if I talk about any point P, always in the coordinate, first value will be in this order pair, the first order pair, in this order pair the first element will be real part and this will be y will be imaginary part. That's what I discussed here. Now point of intersection of this will be origin 0, 0 denoted by O, and from the point P we can draw a perpendicular on x-axis. Now see carefully, any point lying on coming to our coordinate system, we also know that any point lying on x-axis is of the form x comma 0. So same thing here also, this point A will be x comma 0, and as soon as I drop a perpendicular here, this point let us say B, and the coordinate will be of this will be 0 comma y. Here x-axis we are going to, okay, let's take as a note, x-axis is regarded as, x-axis is referred as real axis. So whenever we say real axis, it's nothing but x-axis. And since we know from here, equation of x-axis is always what? Y equal to 0. One basic logic is here, whichever point you take on x-axis, y is always 0. Same logic here also. And its equation is y is equal to 0 because y is always 0. Similarly, second point, this is our y-axis, and this y-axis is referred as imaginary axis. Let us write it here also. This is real axis. X-axis is real axis, whereas y-axis is imaginary axis. So second point, okay, already I don't know. Second point, y-axis is referred as imaginary axis, and its equation is x equal to 0. Let us mention that also here, imaginary axis, and the equation is x equal to 0. Real axis equation is y equal to 0. Sorry, y equal to 0. Now let us try to understand from this about what is this magnitude and conjugate of a complex number. Let's take one more diagram. See carefully. If I take z is equal to x plus iy, the corresponding point will be x comma y here, right? Now just see carefully. Can you say me what is the distance from origin and this point? Which formula will use? Distance formula, school days. What is distance formula for OP here? It is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Origin, the coordinates are 0 comma 0. I'll take as x1 comma y1 here. Nothing wrong, just more space. And this will be x2 comma y2. Let us compute the distance. OP is equal to x2 minus x1 the whole square. So x minus 0 the whole square plus y minus 0 the whole square. X minus 0 will be x and y minus 0 will be y, then square. Oh, see carefully, we got OP is equal to root of x square plus y square. Just before this discussion I discussed, if z is equal to x plus y is given, then what is its modulus? It is root of x square plus y square. So this is mod of z. From the diagram, we are understanding that modulus or magnitude of a complex number denotes distance between the origin and the given point, or I can say distance of the point with respect to origin. So whenever we are finding modulus, what we are finding, this implies modulus of z, which is equal to root of x square plus y square, represents distance of the point P of x comma y with respect to origin. That's it. Next, this is your module. What about conjugate? What was conjugate of x plus iy? Before we go ahead, recall the sign of this in first quadrant, second and third, fourth quadrant. Same sign we are going to have here also, because I said no, whatever we have got real number, in place of real number, as soon as we take complex number on the same, then we call eigenplane or complex plane. So in the first quadrant, both x and y is positive. Second quadrant, x is negative, y is positive. Third quadrant, both are negative. Fourth quadrant, x is positive, y is negative. Now, conjugate of this, what is conjugate of this? It is x minus iy. So the point will be x comma minus y. X comma minus y is somewhere here. I'll take this as some q. X comma minus y. Okay, q is this. So what we have understood, actually conjugate of a complex number is the image of the given point. See, this is the image of this is here, and when I say image, there should be a mirror, and mirror is real axis, nothing but x axis. This is the mirror. This is acting as a mirror. So conjugate of a complex number represents image of the given complex number, where x axis, nothing but the real axis, is going to act as a mirror. Okay, fine. So with this all concept done, just I want to take one last concept with that term. After that we can start with the problems. Kindly make a note of this. Oh, yes. Okay, let us comment on this. So this was the first comment. Or second comment. Conjugate of a complex number. Conjugate of a complex number is an image of the given. Conjugate of a complex number is the image of this is enough. Is the image with respect to real axis, nothing but x axis, and real axis acts as a mirror. Fine. Now, last point I want to discuss. In school days, we have this root of a into b is same as root a root b. There, in school days, it is always taken a and b to be what? Positive, or better I can say non-negative. Non-negative means either positive or zero. Okay, see this. This number line, 0. Right of 0, this all about positive. Left of 0, negative. When I say non-negative, nothing but I don't want non-negative. I don't want negative. When I don't want negative, what's the meaning? 0 as well as positive. Okay. So this is true. But what about if both are negative or any one is negative, other is positive? See, let us take the cases. Okay. This is true for this, no doubt. Now let us suppose that one term is positive, other term is negative. Then see carefully. Let us suppose a is equal to some 3 and b is equal to some -1. Then if I substitute here, I'll get 3 into -1, which is actually same as root 3 into root of -1. Root 3, root of -1 is what? I. So it is 2 actually, because this is what? No imaginary number. So no doubt. And similarly here I have taken a positive, b negative. It can also happen that a is negative and b is positive. Any one of them should be negative and other should be what? Positive. No problem. It holds. What if both are negative? Now let us try to check. If I talk about a to be some -3 and b to be some -5, first let us compute what is root of a into b, the left hand side. So we'll get root of -3 into -5, minus to minus plus 3 5s are 15. Okay, this is your left hand side. I'll take as equation number 1. Now let us talk about right hand side. Right hand side is root a into root b. What is a value? -3. What is b value? -5. Now both are under the root negative, and we have this from here, is it not? 3 into -1 is -3, correct? No. So -3 under the root will be root 3 into root of -1. Similarly, this will be root 5 into root of -1. Root 3 into root 5 will be how much? 3 into 5. And here root of -1. Alright, again, this also root of -1. What is root of -1? I. Again, what is root of -1? I. 3 into 5 will be 15. What is I into I? What is I into I? I square. But what is I square? -1. Correct? We know that I square is -1. So minus to plus is minus. Root 15 is the right hand side, and this is my equation number 2. Now observe both equation number 2 and 1. Here we got plus root 15, but here we got minus root 15. In short, this is not true if both a and b are negative. It's not true whenever both a and b are negative. Right? Just erase there and give the conclusion. See carefully. The conclusion remark will be as a note. Root of a into b is same as root a into root b if what? First, a and b both positive, a positive and b negative. 0 is obvious, okay? Or I will include here. Next, in this, okay, I'll take C case also. A negative and B positive. Okay. Whereas root of A B is not equal to root A into root B if A is negative and B is also negative. Okay. So with this, all the concept done. Make a note. Now you take the problems. Okay. Dear students, let us move on to some properties. Just I'm going to list them. It may be surely required for a problem as well as for 1 marker question. Okay. So coming to the properties, we can say, coming to the properties of magnitude, the other name for this will be modulus. As I just understood, it is distance of the given point with respect to origin. So here the properties are, let us suppose I've got two complex numbers z1, z2, and I want to find the modulus of this. What you may think, multiply whatever z1 is given. Z1 is a1 plus IB1 of mic identified for the while. Yes. On. Yeah. Fine. Sorry for interruption. So Z1 is this, and coming to Z2, it is A2 plus IB2. So in place of multiplying them and then taking the magnitude, property says that we can take modulus individually. Find the modulus of first complex number, then second complex number, and then multiply. Both will be same. See, our properties will be as a shortcut. Okay. Then let us suppose I have got division and I want to find modulus. We know if it is there in denominator I have to multiply and divide by its conjugate. In place of that, this property says no need. You can just find the modulus of both separately, where modulus of Z2 should not be equal to 0. It should be a non-zero number. This is with respect to modulus. We have one more which is not there in NCERT text. Now let us suppose that z power n is given. Nothing but first multiply z n times, then take the modulus. In place of that, take the modulus first and then whatever the power they have said, we can raise it. Okay. Now let us move on to conjugate properties. Conjugate of a complex number. Now, again, if Z1 and Z2 are these two complex numbers, the first one is, let us suppose that I have got addition of two complex number and I want to take on this entire whole conjugate. Okay, whole conjugate. So in place of adding then taking the conjugate, the property says you can take separately conjugate and then add. If I have got subtraction, then subtraction. Here be careful, above with above, below with below. Okay, plus with plus sign, minus with minus sign. Next, let us suppose that we have got for product Z1, Z2, I want to take whole conjugate. This says again, you can split them separately and then after taking conjugate, you can multiply. Next, what if we have division and I want to take on this entire conjugate? Again, the property says again you can take separately, no issues, provided Z2 is not equal to 0. When Z2 is not equal to 0, its conjugate also is not equal to 0. Okay. Now, there are some identities that I would like to quote here. What are those identities? Like a plus b whole square, a minus b whole square, a plus b whole cube, a minus b whole cube, and a square minus b square. Whatever is there true for real number, we are saying that even in complex numbers also it is true. Nothing but if I have been given z1 plus z2. Okay, before I forget, one more point I want to raise here. See, multiplication of z and its conjugate will be mod of z the whole square. Whenever we multiply any complex number with its conjugate, what we will get? Mod of z the whole square. Okay, that you can see here. See this? If I say z is equal to a plus ib, then what is z conjugate? A minus ib. Then what is z into z conjugate? Multiply them. A plus ib into a minus ib. Right? Now, these are from a plus b into a minus b, which I already discussed previously also. Anyway, let us write it. Let us reattempt it. So, this will be a plus b into a minus b, which is equal to a square minus b square. In place of a, we have a itself. In place of b, we have ib. Again, in place of a, we have a. In place minus get balanced. In place of b, ib. So, substitute here. A square minus, in place of b, what do we have? ib. So, here ib, the whole square. So, what I'll get? Let's write square a bit more bigger. So what will get? A square minus CS square of I, then B square. So from here we'll get A square minus I square is minus 1, then B square. So A square minus to minus plus B square. Recall from here, if Z is equal to this, what is modulus of Z? It is root of A square plus B square. So from here what will be, if I take square on both the sides, mod of Z square is A square plus B square. I hope this point is clear. That's what we are saying, that this entire thing is what? Mod of Z the whole square. But what is the left hand side? Z into Z conjugate. So always whenever you multiply Z and its conjugate, what we will get? Square of the modulus. Okay, let's complete this. The same like our A plus B whole square. What is A plus B whole square? A square plus, same way it will follow, plus B square plus 2 times of Z1, Z2. Coming to second, if I have minus here, there will be a minus. Okay, I've cleared both together. Then if I have got Z square, Z1 square minus Z2 square, this is of the form A square minus B square. Okay, yeah. A square minus B square, what? A plus B into A minus B. So I can just write from here itself. It will be what? Z1 plus Z2 into Z1 minus Z2. Next, what if I got Z1 plus Z2 whole cube? Recall the formula. What is A plus B the whole cube? School list for real number. It is A cube plus 3 times of A square B plus 3AB square plus B cube. So in place of A Z1, in place of B Z2, same thing. What I'll get? Z1 the whole cube plus 3 times of Z1 square Z2 plus 3 times of Z1 Z2 square plus Z2 whole cube. And if we have a minus here, there is a minus here and here. So same thing, if there is a minus here, there is a minus here and for the last term. So yes, with this all the concepts done, now we'll start with the problems. Kindly make a note. Okay, fine. Oh, fine. Dear students, now time for question paper problems. And there is some model question paper. And as you know, it is of this academic year. And it's a PU board model paper. Now let us proceed. So we have finished all the concepts. Now only problems are pending. Question number 4. As you know, it's a 1 marker from part A. Question says the conjugate of a complex number. How to find conjugate of any complex number? Come to imaginary part. That is 3. Change the sign. Plus we change to minus. There is no change in the real part. This is the answer. Match it with the option. Option A is correct. Done. Okay. Now see this problem. They said if x plus iy is equal to this, then prove that x square plus y square is equal to 1. Coming to the solution, they didn't ask you to prove this. They said if, nothing but you have to use both left and right. Now there are 2 ways of getting the answer. First way, the way they have given. Since I want x square plus y square, nothing but I want x value and y value. You can see the imaginary unit I is the denominator. So multiply and divide by its conjugate. Conjugate of a minus ib will be a plus ib. Then there is no change in left hand side. Now numerator is a plus ib. A plus ib will be what? A plus ib the whole square. Coming to denominator, a minus ib into a plus ib. Both are conjugate of each other. Just now I discussed one property that now I can say this one to be what? See this. If this is z, then this is what? Conjugate of z. Sorry, conjugate of z. So we know just now we understood z into z conjugate is what? Mod of z whole square. So if I take this as z or this as z, no problem. Both are conjugate of each other. So what will be the mod? How to find mod? sum of the square of the real and imaginary part. So a square plus imaginary part is minus b. Minus is there here. So minus b the whole square. And usually for mod root will be there. But since we have a square, it will get cancelled. Let's repeat again. This will get cancelled. Let's repeat again. Mod of z is root of square of real part and imaginary part. If z is equal to x plus iy. I hope this point is clear. Now, that's what you can see now. X in place of x, a, in place of y, minus b. So root of x square plus y square, nothing but a square plus y is what? Minus b the whole square. Now, root and square got cancelled. So what is the denominator? What do we have? A square plus minus b the whole square will be plus b square itself. Now, see the numerator. This will become a plus b whole square. By using a plus b whole square formula, what is a plus b whole square formula? It is a square plus 2ab plus b square. So in place of a we have a, in place of b we have ib. Substitute a square plus 2 times of a into ib plus ib the whole square. Again I repeat, if I compare this with this, in place of a we have a itself, but in place of b we have ib. Okay. Now, a square plus 2abi, then I square. So this square for both now, I square, then b square, divided by a square plus b square. Right? Fine. So what are we going to have? A square plus 2abi, or is I square minus 1, then b square divided by a square plus b square. Minus plus is minus. So a square minus b square plus 2ab into I. I can separate the denominator, that is a square plus b square, and here also a square plus b square. I have just separated the denominators. And now come back, left hand side is x plus iy. Why I separated? So that I can equate the complex numbers. I want x square plus y square value. Now to find this value, now can't I equate real with real and imaginary part with imaginary? X is the real part, I can equate with this. Y is the imaginary part, I can equate with this. So as per the condition of equality of two complex numbers, so x is equal to a square minus b square divided by a square plus b square, and in place of this y we have here 2ab divided by a square plus b square. Now I have to solve for x square plus y square. First kindly make a note, I am going to erase this. Okay, I hope it's taken. Yeah, let's erase this. See carefully. What do we have? We have to prove that x square plus y square is equal to 1. So let us consider now the left hand side what we want to prove. It is x square plus y square. What is x value? It's here. A square minus b square divided by a square plus b square the whole square. Be careful, in place of x we have this, then we have a square that is written, then plus in place of y is 2ab divided by a square plus b square the whole square. Now the square should be taken for all. So what will we get? A square minus b square the whole square divided by, see the square should be taken for both. Law of exponents, recall what it says, a by b whole power n is same as a power n divided by b power n. Power can be taken for both as it is given whole power, and so here it is whole square. So again it will be a square plus b square the whole square plus again here 2 square. See square is there here, 2 square is 4, then a square b square for each of this divided by, again how, what's the logic, What is a into b whole power n from school days? Law of exponent. This power should be given for both a power n into b power n. So this square for both. So we're going to have a square plus b square the whole square. Denominator is same for both. So LCM will remain a square plus b square the whole square. This is of the form a minus b the whole square. I think I need some more space. Anyway, I hope this is copied. So 2-marker question. But again, as I said, no, after I complete this problem, I will give you the alternate method. First, I'm giving you the textbook procedure. Okay. Fine. So a square plus b square the whole square divided by this is 1 into this will be a square minus b square the whole square plus this will get cancelled, so we'll get 4 times of a square plus b square. Again, this is of the form a minus b whole square. What is a minus b the whole square? It is a square minus 2ab plus b square. So in place of a square and minus balance in place of b square. Okay. So I'm going to substitute this in this formula. So wherever a is there in this formula, a square, wherever b is there in this formula, it is b square. So what I'm going to get? A square the whole square minus 2 times of a square b square plus b square the whole square whole divided by a square plus b square the whole square. Now expand this. What we are going to and here plus 4a square b. I just forgot this. Plus 4a square b square. So 2 to the 4 minus 2 times of a square b square, then 2 to the 4, then 4 times of a square plus b into b square divided by a square plus b square the whole square. What will be the value of this? I can subtract them because this is minus 2a square b square, this is plus 4a square b square, so I'll get a power 4 plus 2 times of a square b square plus b power 4 whole divided by a. If you expand this, okay, what you get? By using the same formula, if you have a plus here, there's a plus. So again in place of a it is a square, in place of b it is b square. So I'll get this would be same way what I have just got in the numerator. So I'll get a, let's write it from here, a square the whole square plus 2 times of a square b square plus b square the whole square. 2 to the what? 4. So I'm going to get same as the numerator. Both will get cancelled. Answer is 1. Answer is 1. But in place of doing so much, we have alternate. Let us talk about that. Okay, let us talk about the alternate method. First, make a note of this. Okay, what is the alternate method? See carefully, pay attention. In the question, what they give? Let us check the question. Yes, dear students, same problem I have taken. Now see the other way. And this, whatever method I am using, it is by properties. See carefully this, what they have given and what I want. Here, if you observe this and the right hand side, means whatever I have to prove, is it not this is modulus of this? Check it out. Solution. Taking modulus on both the sides. Taking modulus on both the sides. So x plus iy mod is equal to modulus of a plus ib divided by a minus ib. Now here have to take mod root of sum of the square of real part, then imaginary part. Here also separately I can take modulus. We discuss the property that modulus of z1 by z2 is always same as mod z1 divided by mod z2, where mod of z, okay, where z2 should not be equal to 0. So same thing here, no? Mod of this is what? Root of a square plus b square. Coming denominator, root of a square plus What is imaginary part? Minus b. So minus b the whole square. Now very clearly you see this will be root of a square plus b square divided by this will be root of a square minus z, but square will convert negative to positive. See what we got? Both are same. Cancel 1. So ultimately we are going to have root of, okay, root of letters is here. But in the question means what we want to prove, root is not there. So what I can say, on squaring both the sides, on squaring both the sides, we are going to have x square plus y square is equal to square of 1 is what? 1 itself. That's what they wanted. Okay, and we got the solution. In no time we got the answer. Make sure you mention the properties there. Okay, kindly make a note of this. Dear students, let us move on to the next problem. And for this, no, there is no property the way we just completed. Okay, as we can now, how to know that? See, in the previous note, as soon as we took modulus, we got square of the term, sum of the square term. Here, if you see, if I take modulus, no, here you have negative. If it is plus, then we could have thought of properties. That's what I said. No method is my favorite method. Okay. Question says, from model question paper number 1, question number 33. If x plus iy whole cube is equal to u plus iv, then show that this thing. For this, surely I want the real part and imaginary part. Coming to the question, x plus iy the whole cube is equal to u plus iv. This is the form a plus b the whole cube. What is a plus b the whole cube formula? It is a cube plus 3a square b plus 3ab square plus b cube. Correct? So in place of a we have x, and in place of b we have I into y. Substitute here. Then what I'm going to get? If I substitute a, so wherever a is there x, wherever b is there iy in the entire thing. So I get x cube plus 3 times of x square into ib plus 3. Again in place of a it is x, and in place of b it is I into y square, then plus b. What is b? I into y whole cube is equal to u plus iv. Now let us recall law of exponent. What is a into b whole power n? A power n into b power n. So here x cube plus 3x square y, I can write at the rightmost, plus 3x here, then square should be taken for both, so I square into y square plus cube also for both by using this law of exponents. So I cube y cube is equal to u plus iv. Now let us simplify. What is I square? Power of I we have discussed. I square is minus 1. What is I cube? Minus I. So using that, first there is no change for this two term. So x cube plus 3x square y into I. Then I square is minus 1, correct? So 3x minus 1 into y square. Then what is I cube? Minus I. So minus to plus will be minus I. I cube is minus I. So minus I here. So y cube is equal to u plus iv. Anything? All you got properly. Now let us rearrange real part and imaginary part. Real part is that term which is not a multiple of I. So this term and this term are not multiple of I. So x cube plus into minus minus 3xy square. Then imaginary part is this two, because multiple of I is present. So I. So here it is 3x square y, and here it is minus y cube. Minus y cube is equal to u plus iv. Now see this step. Here now we can think of equating real with real and imaginary with imaginary and try to solve for left hand side. So on equating, real part is this, and here it is u. So u on equating, you get x cube minus 3xy square is equal to u, and the imaginary part is this 2. So 3x square y minus y cube is equal to v. Now you see what we want. We want u by x plus v by y. So on either side here, since I want by x, divide by x here, what I'll get, x cube by x minus 3xy square by x is equal to u by x. And since here we want v by y, v is already there, I want by y, so divide by y. So here 3x square y by y minus y cube by y is equal to v by y. Now let us simplify. This x, one term will get cancelled, this x is gone, and here 1y gone, y is getting cancelled, and here 1y, so y square. So what is left out? Left out is x here minus 3y square is equal to u by x, and here it is 3x square minus y square is equal to v by y. Now let us write on the left hand side. Consider what? U by x plus v by y, u by x plus v by y. See carefully. U by x value and v by y expressions. Okay, expression I mean to say. So u by x is a x minus 3y square, and v by y is 3x square minus y square. Kindly make a note. Here is x square, so square I have missed. This term is here, square I have missed. Okay, fine. Now what is x square plus 3x square? 4x square. And what is minus 3y square and minus y square? Minus 4y square. And what is common here? 4. So I'll get what? X square minus y square. Left hand side, don't forget, u by x plus v by y. Job done. Have you got? See carefully. A 3-marker question. Yes, kindly make a note, and there's no other way than this. Okay, kindly make a note of this. Dear students, now time for model question paper number 2. Question says the additive identity of this complex number is. See, recall, let it be any complex number z. If at all I want z back, I have to add with 0 only. Same as 0 plus z. So let it be any complex number, irrespective of whatever given here. As soon as they said additive identity, it's always 0, and 0 is same as what? 0 plus I into 0. Option B is correct. Purely concept based. Next, the standard form. I said no when I was taking PUC problem. In place of saying write in the form of a plus ib, they can also say standard form. Nothing but I should have z, the complex number form. Z is equal to a plus ib. See carefully now. For simplification, minus 5 into 1 will be minus 5 by 8. I into I square. What is I square value? Minus 1. I want power of I to be 1. Here we have 2. I square is minus 1. So we get minus 5 by 8. I square is minus 1. Minus to minus plus 5 by 8. Look at it here. And since I want imaginary part, there is no imaginary part, purely real. I can say I into 0. 5 by 8 plus I into 0. Option D is correct. So in this model paper, we got 2 1-markers filling the multiple choice question. Okay. Now let us move on to question number 22, which is a 2-marker problem. Okay. All fine now? Yes. 2-marker question, and here you can see power of I. See, first I power 18. Can't write I power 18. Multiple of 4. 4 4s are 16. plus 2 will give you 18. Then here, as I said when I started, that make sure power should be always positive. So I can write 1 power 25 is 1 itself divided by I power 25. Okay, so now I can write step by step. Okay. Reason a by b whole power n is same as a power n divided by b power n. Now, as I said, always you see this remainder. That's going to set the values of what are the value means what are the powers given. I power 2 plus 1 power 25 is 1, and here I power 4 6 are 24, but I want 25, so plus 1. I squared is minus 1, and here plus I power 1. What is 1 by I? It is minus I. So I'll get minus 1. 1 by I is minus I. So this is the solution, or when I express this in the standard form, this is the answer. Real part is minus 1. Imaginary part is also minus 1. Kindly make a note of this. Okay, dear students, from model question paper number 2, we have 2 questions on 2 marker. The question says find the multiplicative inverse of. Coming to the solution of this, first recall. Okay, first let us equate this one to z, the complex number. Recall the multiplicative inverse is given by z conjugate divided by modulus of z the whole square, where modulus of z should not be equal to 0. This we have derived. Now just find both and then substitute in this equation. Conjugate of z. From here, conjugate of z. How to find conjugate? See the imaginary part, it is minus 3, that is multiple of I. Change the sign, minus 3 to plus 3. This is the conjugate. Now mod of z. Come on, mod of z is equal to root of, recall the formula. If z is equal to x plus iy, then what will be modulus of z? Root of sum of the square of real part and imaginary part. So here my real part, if I compare, in place of x we have 2, in place of y we have minus 3. So 2 square plus of minus 3 square. Now observe carefully. Many students will write minus out here. No. See the formula. Plus of imaginary part. So plus of imaginary part is minus 3. Now since we have square, I'll get positive term. 2 square is 4 plus minus 3 square is 9. Then 4 plus 9 will be 13. This is modulus of z. But I want square of the modulus. Okay, on squaring, modulus of z will be 13. Okay, so this is my equation number 1. So and I will take this as equation number 2 and this as equation number 3. So finally put equation number 2, that is this, and 3 back in 1. So 1 will be z inverse is equal to, conjugate of z is 2 plus 3i, and modulus of z is square is 13. This is your answer. This is the inverse of, multiplicative inverse of the given complex number z equal to 2 minus 3i. How to know whether the answer is correct or not? Multiply this 2, you should get 1. And this is very obvious. When you multiply, since this and this both are conjugate, what you will get? What is z into z conjugate? Problem completed. I'm just saying how to verify. What is z into z conjugate? It is mod of z whole square. So when I multiply this and this by using this property, I'll get mod of z square, nothing but 13. 13 by 13 what? 1. Like this you can cross check. Okay, with this model question paper number 2 done. Coming to model question paper number 3, the value of minus root of minus 1 whole power 4n plus 2 is when n is a natural number. Solution. Question is given minus root of minus 1 whole power 4n plus 2. Very elementary question. First, recall what is root of minus 1. We are denoting as iota I. So we will get from here minus, then this entire thing is I. Whole power 4n plus 2. Be careful. 4n is even, 2 is also even. So whenever power is what? This entire power is what? Even. Whenever power is even, negative will convert to positive. Then 4n plus 2. Recall, I said you, when you write in the form of multiple of 4, remainder will decide. Remainder is what? 2. I power 2. What is I power 2? Minus 1. Minus 1, option D. Option D is correct. Okay, kindly make a note of this. Okay. Dear students, these are the last two problems from the model question paper number 3. A 2-marker question here. Express the complex number 1 minus I whole power 4 in A plus IB form. Now see carefully. Don't think, no, I have to use some formula of A minus B whole power 4. No, not required. Just a common sense will work out here. Can't I write this one as 1 minus I square, the whole square? Because from law of exponents, A power m whole power n will be A power m into n. I can multiply the power. So 2 into 2, 4. Now, the term which is there inside the rectangle box, nothing but this. For this, I can use the formula A minus B whole square. What is A minus B whole square formula? A square minus 2AB plus B square. If I compare this two, in place of A 1, in place of B, I it is. Just comparison, minus and minus will get balance. So we will have A 1 square, then minus 2 into 1 into I plus I square whole power 2. Okay. Now 1 square is 1. Then minus 2 into 1 is minus 2 I square. What is I square? Minus 1. The whole square as it is. I square is minus 1. Now very clearly, can you see plus 1 and minus 1 will get cancelled. So we will get minus 2I whole square. Now this square, by using law of exponents, that is A into B whole power n is A power n into B power n. So this square for both. So we'll get minus 2 the whole square into I power 2. Minus 2 whole square is 4. And what is I square value? Minus 1. I square value is minus 1. Plus into minus minus 4. There is no imaginary part. So I can write this one as plus 0 iota into 0. Nothing but this purely real. This will be the standard form of this complex number. I hope this is clear. Let us move on to this. Find the conjugate of this. We have two ways to solve, but both will be the same length. First, you can take conjugate. Then make sure I should not be the denominator. Multiply and divide by its conjugate. Otherwise, is first we can take the simplify and make denominator should be free from I, and then take the conjugate. Both are fine. So let the given problem, this is the last problem for 3 marker. Let ZB is equal to 3 minus 2i into 2 plus 3i whole divided by 1 plus 2i into 2 minus I. Now just multiply. 3 should be multiplied to both the terms. 3 2s are 6 and 3 3s are 9 with I. So what's the answer? 3 2s are 6 plus 3 3s are 9i. Okay. Let us not have any bracket. Fine. Then minus into plus is minus. 2 2s are 4. Sorry. 2 2s are 4i. Minus into plus minus. 2 3s are 6. I into I square whole divided by. Again here also. 1 I should multiply with both the terms. 1 into 2 minus I will be 2 minus I itself. Then 2 into 2, 4, 4I it is, plus 4I. Then 2 into minus 1 will be, see there is nothing, means minus, here minus is there, here the number is what, 1, correct? No, so minus 2 into 1 is minus 2. What is I into I? I square. Again recall what is I square value, minus 1. And how to add or subtract any two complex number? Real with real, imaginary with imaginary. So see carefully. 6. What is 9I minus 4I? It is plus 5I, because 9 minus 4 is 5. Then minus 6. What is I square? Minus 1. Whole divided by 2. What is minus I plus 4I? Plus 3I. Signs are different, I have to subtract. And here nothing is there, means what? Always 1. And since minus is there, minus 1 it is. Minus 2. Again I square is minus 1. Again simplify this. What we are going to get? 6 plus 5I. Minus minus plus 6 ones are 6. Divided by 2 plus 3I. Minus minus plus 2. Now simplify. What is 6 plus 6? 12 plus 5I. Divided by 2 plus 2, 4 plus 3I. Let's solve this side. First, kindly make a note of this problem. I'm going to erase this. I hope it is done. Okay. Means surely you can pause the video and you can copy, correct? No? Okay. Fine. This is solution, okay? Yes, for you. Yes. Now I want to remove I from denominator, so I'm going to multiply and divide by its conjugate. So I have got 12 plus 5I divided by 4 plus 3I. Multiply and divide by its conjugate. Conjugate of 4 plus 3I will be 4 minus 3I. Again 4 minus 3I. Now multiply. 12. 12 into 4 will be 48. Then 12 into minus 3. So plus into minus minus. 3 into will be 36. Correct? 3 to the 6, 3 to the 3. Then I. Then 5 into 4 will be 20. I. Then plus into minus is minus. 5 into 3, 15. I into I square, divided by, see carefully, these two are conjugate of each other. So we know in place of multiplying and wasting the time, no, we know the result. Z into Z conjugate is modulus of Z square. So here our Z, okay, this Z is for the question. So to just compare with the problem, so see this 4 plus 3I into its conjugate should give me square of the modulus. Nothing but 4 square plus 3 square under the root, but we have a square, so square and root will get cancelled. Mod Z is giving this value, correct? No, what is mod Z? What is mod Z? Root of x square plus y square. So we can treat this 4 to be x and y to be 3. Or even you can take x to be 4 and y to be minus 3, but minus 3 whole square will be plus 9. Okay. So you can see root and square got cancelled here. So 4 square is 16, 3 square is 9. We are going to get 25. Okay. So the denominator value is 25. Okay. Now 48 as it is. Here both are imaginary parts, so signs are different. Subtract. Minus 36 plus 20 will be minus 16I. Then minus 15. What is I square? Minus 1. Divided by 25. Now plus 48. Here minus to minus is plus. 15 ones are 15. Then minus 16I. Whole divided by 25. I can split real part and imaginary part. First you add this 8 plus 5 will be 13. Borrow 1, 63. 4 plus 1, 5 and 1 borrow 63. Then minus 16I. Here divided by 25. Here also divided by 25, as 25 dividing both. This is our complex number. We have brought it to standard form. But the question is to find conjugate. Let us find the conjugate. How to find conjugate? Change the sign of imaginary part. So this will be 63 by 25. Imaginary part sign is minus and the number is 16 by 25. Minus will change to plus. 16 by 25i. So this is the answer for our problem. This will be the conjugate. With this, all the questions from the model paper is completed. First, make a note of this. So dear students, with this, all the concepts is been discussed. That's the reason the video went a bit lengthy. See, as I said when I was recording permutations and combinations, I said the entire chapter concepts along with the model question paper problems, it will be uploaded. Yes, I stand with my words. Surely, at the earliest, I know your exams on 10th, at the earliest, it will be uploaded max to max coming Monday to Tuesday. Hope so. Everything should be done. I'll try my level best. So all the very best. Study well. Do practice. Write and practice. Okay. All the very best. God bless you all. Take care. And do like, share and subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you.